Now, machine learning, I'm using ML to refer to it instead of writing out machine learning every time, but it has a very wide variety of applications. Very wide, like too many applications to even list here. So I just listed a few here. So email filtering, computer vision, loan prediction, sales forecasting. So they seem to be very different domains, right? Email filtering is very different from computer vision, which is very different from loan prediction, which is completely different from sales forecasting, right? But what they all have in common is they're using machine learning principles and the concept of developing conventional algorithms to perform certain needed tasks, but doing so in a way where you don't explicitly program it to perform a certain task, but it's able to learn from data. Now, why machine learning? This is an important question that many people ask. Why, if you are a good programmer and you can leverage that and you can write, programs and you can automate a lot of tasks, why do you need to use machine learning? And how do you know when to use machine learning? So there are a lot of problems that computer scientists have encountered throughout the years, and a lot of problems that are very difficult to solve using conventional programming methods. So there's certain problems that are very hard to write programs to solve. And, an example would be facial recognition. So if you were to apply a conventional method in order to write a program to perform facial recognition, it would be extremely, extremely difficult. And there are a lot of problems like this that pop up that have long been known to be extremely difficult, facial recognition, recognizing handwritten digits, and so on and so forth. And the reason some of these problems are difficult is because, initially they seem like they should be solvable because they're tasks that are so easy for us to perform as humans. But when you really, think about it, we don't really know how our brain performs these tasks. And the thing is, these tasks are so complicated that even if we did know how our brains perform them, we would, really struggle writing a program to mimic that. And even if we could, the programs would be extremely complicated. So instead of writing a program by hand, which is what conventional programming does, we can instead collect a lot of examples that specify the correct output for a given input. Okay. So in the case of facial recognition, we can collect millions of examples of data of images, and we can classify them. We can specify that which image or which digit is the correct one based on our own human input. And we can take that data and feed it into a machine learning algorithm, and the machine learning algorithm can learn from that data how to classify new cases. Okay, that's essentially what machine learning is. And the point of machine learning algorithm is that you do have to have a lot of initial data that you yourself have classified so the program knows which are which. But the point is to get the algorithm to a level from which it can actually recognize new images. So this tends to require a lot of data, but in the end, you are able to predict new cases. That's basically the gist of machine learning. And so some of the requirements for machine learning to work or to be able to implement machine learning is that there must be some pattern between the input and output of the data. So let's take the example of handwritten digits. So imagine you have a bunch of handwritten digits from a bunch of different people. You had people write down the letters like the number 0 to 9, and you collected tens of thousands of these, and you scanned them, and then you oriented them, and you labeled each of them. So when there's a 6, right, you yourself have typed in 6 there. So any program, any model that's being fed this data will know automatically what digit each image is, okay, because you've labeled them yourself. Now, there is a pattern between this image and your label of it, because everybody writing that digit knows that writing that digit. So for example, the number 6, everybody writing number 6, their hand generally moves in, some motion that results in 6. So there might be some differences in the way people are writing the number 6, but in general, they're all using some of the same actions. So there is a pattern. Let's take another example. For example, if you want to predict loans, and as an input you take in many cases of people, or you take in data of people, their past loans, how much they've loaned before, how long it's taken them to pay, how long it takes them, how late they are paying their normal bills, how often they use a credit card, and that kind of stuff. Okay, and you take those kind of inputs, and you're trying to predict which of them will fail to pay back their loans or succeed in paying back their loans, what you're basically doing is trying to find a pattern between actions of people and whether or not they pay back their loans or not. And most probably there will be some pattern. If people tend to not pay their bills on time, we can probably assume that they're most likely to also not pay their loan back on time, right? So there is some sort of pattern. We don't have to know exactly what that pattern is. The machine learning algorithm will discover that for us, but it needs to at least logically make sense that there might be a pattern. And this relationship or this pattern between the input and output of the data should not be completely random, right? Otherwise, there's no point in applying machine learning algorithms to it. So an example you can see on the slide is lottery winning numbers, right? It's impossible to predict lottery winning numbers because it's completely random, okay? So you can only apply machine learning to problems in which you have an input and output that have a relationship, okay? And on top of that, you need to have enough data that you can actually discover this relationship. So you need to have quite a lot of data. And depending on some problems, you might need more and other problems might need less. But you need to have enough examples so that the machine learning model can actually train itself and fine-tune itself to find that relationship. Now, one important thing to note is that if there is a very clear mathematical relationship between an input and output, or like a very clean set of rules that can lead you from any input to the correct output, in that case, it doesn't make sense to use machine learning, because then you could just write a program to follow those steps and there you go. You have your model, right? Because the whole point is we want to develop a model where we can have inputs mapped to the correct outputs, right? When we see a certain image, we want to be able to know that this image refers to a tiger or a bird. When we see a certain image of a digit, we want to be able to know if that is 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? If we see a particular set of data for an individual, we want to know whether or not his loan is likely to succeed or not. If we see a certain email, we want to know whether or not that email is spam or not, right? So it's all input and output. Now, if there's a very clear relationship between the input and output to the point where you can just arrive at a conclusion based on just the data itself without really training anything on it, then you can just use that relationship as long as it's accurate. Machine learning comes in handy when there must be some sort of relationship, but you can't really figure out what it is. And there's no clear-cut, mathematical or systematic way to figure that out. That's when you can use a machine learning algorithm. So some of the tasks that are best solved using machine learning instead of other more traditional methods is anything that involves recognizing patterns. So this can be, facial identities or racial expressions, handwritten or spoken words. So, basically computer vision, recognizing stuff from visual input or from auditory input or text input, right? Understanding, arriving at conclusions based on text, recognizing anomalies. So, being able to recognize unusual sequences of credit card transactions. Now, this is a very good example because, as a bank, for example, you keep track of all the activity of a particular bank account. So all the money that's being put in, pulled out, and all the credit cards associated with a certain bank account and how often they're used and that kind of stuff. And so this is a lot of input data. And based on this input data, and occasionally you have unusual credit card transactions that happen, which is a clear output. And you assume that there must be some sort of relationship between this input data, all this data that's existing around credit cards in your system. And so there must be a relationship, but it's too difficult for you to really figure out on your own. So that's where machine learning comes in. It builds a model in which you can input all of this input data you have, and it'll predict for you the unusual sequences, of credit card transactions, for example, or unusual patterns of sensor readings in a nuclear power plant, or unusual sound in your car engine, etc. So these are all examples of tasks best solved with machine learning. Also prediction. So future stock prices or currency exchange rates. If you do believe that there might be some sort of relationship in it and it's not completely random, this can be solved using machine learning. Employee attrition, the probability, which of your employees is most likely to quit or to leave the job, using input data such as, how long they've been at the job, how much they're getting paid, when their last pay raise was, the type of job they're doing, etc., etc., and loan defaulting, as we've discussed. So there are many examples. If you go into Google and you write examples of tasks best solved with machine learning, you'll see, hundreds and hundreds of examples. I'm just writing here a few. Some more examples like spam filtering, fraud detection. So being able to detect fraud, being able to detect spam from amongst all your emails, recommendation systems like Netflix recommendation system, where they can recommend for you a movie you might like based on your past viewing history and that kind of stuff. Autonomous cars, as we all know, speech recognition, image classification, tagging, we've discussed language translation, price prediction, advertising, playing games. So playing games nowadays has been pretty popular. Go has been beaten StarCraft, chess quite some time ago. But see, chess was beat quite some time ago, but then it took a long time for Go to be beat as well. And they really leveraged modern, machine learning, deep learning, where there is a clear relationship between the input and output, but it's so difficult that you can utilize the power of machine learning.